Okay, looking at functions and inequalities. Now, if we look in the case of a rational function, so we have r of x is equal to x squared minus 9 over x plus 1. And we're looking at determining the solutions where we have the rational expression is less than or equal to, greater than, and greater than or equal to 0. Okay, we had to establish our zeros. Okay, and in factored form, we have x plus 3 quantity times the quantity of x minus 3 all over x plus 1. And we have with the zeros. Now we have from the numerator, we have for x plus 3, we have negative 3. From x minus 3, we have positive 3. And we have with x plus 1, okay, we have negative 1. And now, let me mention this. Now, negative 3 and 3 will set the rational function equal to 0. However, negative 1 would set x plus 1 to 0. And guess what? Now, a defined fraction in the real number system cannot have a 0 denominator. So we have with negative 3 and positive 3. Now, those values will be in the domain of r of x. However, in the case of negative 1, it will not be in the domain, okay, since that would set the denominator equal to 0. Okay, and now, but we're still going to use all three values in terms of creating the pathway to determining the solutions of each inequality. And we have, in setting up our table, again, so we have the smallest of the three zeros will be at negative 3. So we have with the first interval, okay, so we have between negative infinity and negative 3. And then we have next in line, okay, we have going past negative 3, approaching negative 1. And then we have going past negative 1, approaching the third and highest of the zeros. So we have approaching positive 3. And then we have completing, we have the set of those values x that will be higher than 3. And we have, in terms of setting up what we have as a table. And again, we're going to apply tested values, okay, representing each interval section. And so we have, in setting up, and go ahead and divide up here, okay, just distinguishing the column headings. And categorizing. Okay. All right, so we have, first of all, okay, for the test value x, okay, we can select any value that is less than negative 3 as a sample. Negative 4 will fit the bill. And we have between negative 3 and negative 1. If we were to select integers, we can only choose negative 2. And between negative 1 and 3, but not including negative 1 or 3, okay, 0 will fit the bill. And then we have for anything greater than 3, okay, we have 4 is a viable choice. Okay. And now, for what we have in the case of looking at the value of r of x, and again, we have r of x equal to x squared minus 9 all over x plus 1. And looking at the value of r of x, so we have for r of negative 4. Okay, now negative 4 squared is 16. 16 minus 9 is 7. And negative 4 plus 1, okay, is going to be negative 3. Okay, so we're looking at 7 over negative 3. So r of negative 4, this is going to be negative 7/3. Now, in the case of negative 2 for x, negative 2 squared is 4, minus 9 is negative 5. Negative 2 plus 1 is negative 1. And negative 5 over negative 1, that is going to be a positive 5. Now, if I plug in 0 for x, so I have negative 9 over positive 1, so that will come out to a negative 9. In the case of what I have for 4, so again, have 4 squared is 16 minus 9 is 7, and we have 4 plus 1 is going to be 5. So R of 4, that's going to come out to positive 7/5. And so, looking at what we have resulting from each subinterval, and we have, in the case of the sine of R of x, okay, so we have for the sine of the function, okay, so anything we plug in that is less than -3 for x, the output is going to be negative. So we have the R of x is less than 0. And then we have anything we select greater than -3 and less than -1 for x. Okay, the result is going to be a positive function value. So we have R of x is going to be greater than 0. And then anything we select greater than -1 and less than 3, okay, we have a negative output. So we have the R of x is less than 0. And then anything we select greater than 3, the output is going to be positive. So we had the R of x is greater than 0. Okay, and so for what we have, okay, for our inequality solutions, okay, so whereupon we have R of x is going to be less than 0, and we'll have for the solution where R of x is less than 0. Okay, so you had those values of x that will be less than -3. Now, so you have R of x is less than 0 for those values of x, okay, where we have -1 is less than x is less than 3. Okay. Now, where we have R of x is less than or equal to 0. Now, we're heading in the same direction as where R of x was less than 0. So you're looking at applying the same numerical values, but in closing, you might have brackets along with the parenthesis that goes around -infinity. And let me mention, so you have, again, we established the zeros at -3, -1, and +3. Now, both -3 and +3 are in the domain, and for those inequalities where we have an equal sign, we can place brackets. But anything that is not in the domain, we still maintain the use of parentheses. So -1 is not in the domain, -3 and +3 are in the domain, and just using a little bit of color coding, so you have -3 is in the domain, +3 is also in the domain, and again, -1 is not in the domain. So again, this is what your solution would be for x squared minus 9 over x plus 1 is less than or equal to 0. So we can put brackets only around those zeros that are in the domain, but for those zeros not in the domain, we maintain the use of parentheses. Now for R of x is greater than 0, okay, where R of x is greater than 0, okay, and going back to our table, R of x is greater than 0 for those values of x between but not including -3 and -1, and also we have those values of x greater than 3. Okay, and so we have for that solution, okay, so we have parentheses exclusively since we don't have an equal sign in the inequality. Okay, so that'd be your solution set for R of x is greater than 0. And if I have the R of x is greater than or equal to 0, I'm still taking the same limits, but the enclosures, okay, will be potentially different. Okay, now again, we have infinity is boundless, so that stays in parentheses. And now again, -3 and +3 are in the domain, and since the inequality has the equal sign, again, we can place brackets around the negative and the +3, and in spite of the equal sign, okay, again, -1 is not in the domain since that value causes the denominator to be equal to 0, which is not allowed in the real number system. Okay, and so these are the respective solutions we will have for R of x. So less than 0, less than or equal to 0, greater than 0, and also greater than or equal to 0.